Hi everyone, welcome back to my channel. Today in this video we're going to discuss about the SD-WAN security. Okay, and within this, first we need to discuss um, about the difference between confidentiality versus authentication. Okay. Second, we're going to discuss. Then we're going to discuss about the confidentiality, integrity, and authentication to see the complete picture of SD-WAN security. Okay. And the third, we're going to see how the transport layer security TLS work for the control connection. TLS for control connection. Fourth, we're going to see IPsec protocol, or you can say the IPsec tunneling, which we going to see for data data traffic, or you can say data tunnel. So what is the role of the IPsec tunnel for creating the data traffic or for passing the data traffic between vEdge routers, vEdges. Okay. And the fifth one, we see how we can achieve the security, the concept of uh, CIA in SD-WAN security. Okay. And how we're gonna achieve this in Cisco SD-WAN. So basically, there is a difference between confidentiality and authentication. Okay, to see the difference, basically what we're gonna see is um, we need to remember the data which is encrypted with public key can only be decrypted with a private key, and vice versa. That we know, that we already know, as I've mentioned the same thing in my last videos also. Okay, and and we will encrypt the message using the public key of the receiver, which will only be decrypted with the private key of the receiver. So basically, in authentication, what we will do is this: we have a public key and we have a private key. For laptop also, we have a public key, we have a private key. And for this is a certificate authority, which we have discussed. For that also, we have public and private. So let's suppose it has public key A, private B, C, D, and this one E and F. Okay. So what the confidentiality is, when we encrypt the message using a public key, okay, we will only decrypt it with the private key. If any message which is encrypted with this public key, the public key of the server, okay, that will only be decrypted with the private key of the server. Okay, so as we have discussed earlier, or in my last videos, we have discussed that uh, when the server pass on the certificates towards the destination, in that certificate it will also send its public key, which is C. Okay, and when this public key C will receive at the laptop end, and when the laptop will send a data, okay, it will encrypt that data with a public key of the receiver, which is C. Okay, and when that data will receive at the server end, okay, The server will decrypt that data using its private key, which is D. And this is how data transmission happen. Okay, and this is how the confidentiality is different. So now we will see how confidentiality is different than authentication. So let's suppose if this laptop is trying to talk to this particular server, then we should be sure that this is a valid server. Okay, so if laptop is trying to reach this server, then it should make sure that this is a valid server. So this laptop has to authenticate this server so that you can go ahead and communicate with the server. Okay, so in that case, the bank server must give some kind of proof to the laptop that I'm a trusted entity. Okay, so the whole goal is to prove the server that yes, I am the right server through which you will get the required information. Okay, so now what the server has a document which might include it's a document which includes its name of the server, and other details. Okay, so we will encrypt that message using a private key of the bank server. So this document we will encrypt using private key of the server, which is D. But during confidentiality, we were using public key of the recipient to encrypt the message. But now, during authentication, we use private key of the server, okay? Or we are using the private key of the recipient or the receiver to encrypt the message. So the first difference here is in confidentiality, we are using public key, okay, for encryption. But in authentication, we are using private key for encryption. Okay. Now the process is that the server will send this particular document, the server will send this document containing the name of the organization or the details, and put its public key within that document. Okay. Server will server So this document is encrypted by a private key, okay, which is D, okay, but it will put its public key C within this particular document, okay, and then this document will be signed by a certificate authority. Okay, so this document will reach to certificate authority, and certificate authority will sign this particular document. Okay, so this document, which will include the public key of the server, which is C, and this document will sign by a certificate authority. So the certificate authority will generate a hash value out of the message, which includes the public key of the server. Okay, so it will in so the certificate authority will uh, use SHA to generate the hash value of the message which is within this particular document. Okay, so the certificate authority will also encrypt a hash value using its private key. So when the certificate authority will generate a hash value, so this hash value is also encrypted, okay, using the private key of the certificate authority. So the hash value is encrypted. Okay, so when the certificate authority will encrypt the hash value using its private key, which is F, So that means this encryption of the hash value, okay, by a certificate authority using its private key is basically the signing a document. Okay, it is same thing. Okay, now what the certificate authority will do, certificate authority will send that signed document back to the server. So we got this document back from the certificate authority, and this document is signed. Basically, this document is encrypted. The hash value is encrypted by private key of certificate authority. Okay, encrypted by private key of certificate authority. And this particular document we called as certificate. So this certificate is like a document which is certified by a certificate authority. Okay, so this certificate is certified by the certificate authority so that the laptop can trust this particular server that yes, I am a valid device or valid server which you are trying to reach. Okay, so this certificate will contain its validity also. Okay, so when this document got signed, it also include its validity. So this document also have its validity. So validity means for how long this certificate is valid. Okay, and the sign sign of the certificate authority. So this certificate authority approved the authenticity of the bank server. Okay, so this certificate means certificate authority approve the authenticity of the server. Once the certificate authority approve the authenticity of the server, okay, the certificate authority public key, it it has a public key of E, and that key is available to the laptop also. Okay, so the laptop will also have public key E of the certificate authority. So certificate authority sends its public key to the laptop, which is called the root certificate because it contains the public key of certificate authority. Okay, so the public key which is sent to the laptop by certificate authority is called the root certificate. Okay, and when we install root certificate in laptop or in laptop browser means the laptop has the public key of the certificate authority. Okay, and I'll also show you how to check the root certificate on a laptop browser. Okay, to check the root certificate on a laptop browser, what we have to do, these this is a sign basically. So we have to click on this, okay, and we need to select the connection is secure. So that means this connection is secure. And when we open this connection, okay, and you can see this certificate is valid. It says the certificate is valid, and when I click on that, we'll get the details of it, like the common name, organization name, okay, and the validity of the certificate. So this it's kind the same document uh which will be sent by the server to the certificate authority, and this is the certificate basically, and this SHA-256, okay, SHA-256 is the hash value which will be generated. Okay, so and this hash value is encrypted value. Okay, and this is the general certificate view, and this is the complete details. So this ident true, we have this ident true. Ident true is a certificate authority which is uh, which is a trusted entity that issue the digital certificate used to verify the identity of a website or any organization. Okay, and this is basically an entity which can secure the communication over the internet also. Okay, and this is a widely recognizable entity and trusted by major browsers. Means you can find it on Mozilla uh, Firefox also. Okay, and multiple system and devices also, system operating systems also. Okay, so you can see its details of the algorithm. Okay, SHA is used for hashing and RSA for key exchange. Okay, so this is how we can go ahead and verify the certificates on a browser. So as I show you how we can see the certificates on a laptop browser. So these certificates use SSL or uh, TLS certificates for websites. Okay, so now when so on this topology, now when the laptop will try to communicate with the server, okay, the server will send the certificate, which is basically a same document, okay, and this document contains the information like the organization details, name, okay, and this document will have the public key of the server, which is C, and it's also signed by certificate authority, and this whole document is now a certificate. Okay, so this server will send this certificate. It will send this certificate to the laptop. So this certificate will go to the laptop. Okay, and also this certificate also includes its validity. Okay, validity for how long the certificate is valid. Okay, so laptop already has a public key. As mentioned, the certificate authority also sends its public key to the laptop. So it also has the public key of the certificate authority, which is E. Okay, and now it also got the certificate. Now the laptop will use the certificate authority public key to decrypt the signature to confirm the authenticity of the server. So the laptop will use this public key of the certificate authority to decrypt the signature. So this signature, document signature, was encrypted, as I mentioned earlier, it was encrypted by the private key, which is F of certificate authority. Okay, and this laptop will use its public key to encrypt the message. This is how the authenticity will work. So this whole process or uh, sharing the certificates and getting the trusted entity is called the public key infrastructure. Okay. So now the question arises, who is distributing the public key of the bank server? Okay. The public key of the bank server is distributed within a certificate. Okay, because as I mentioned, within this particular document, we have a public key of the certificate. Okay, so this key, along with the public key of the certificate authority, the laptop will also get public key of the server, which is C, within that particular certificate. In SD-WAN, we are going to authenticate different controllers using these certificates. Okay, and that's why the certificates are very important. Okay, so in SD-WAN, the role of certificates are very important, because every for every device the authenticity will check through these certificates. Okay, so the authenticity of the devices, as in the controllers or edge routers. Okay, for these devices, the authenticity will be checked through certificates. As in this topology in SD-WAN, basically this server is will be vBond or vManage. Okay, and we will take all information from these controller devices and put that in certificate authority. Okay, and certificate authority will sign it. Okay, make sure the device is a trusted device to which the edge device is trying to reach, or the edge device is trying to make a control connection. So after this laptop confirm that this server is a trusted entity by checking its certificate, okay, it will go ahead and send the data to this server. Okay, and the data must be secure because we are sending the data over a internet connection. Okay, and the secure data, to secure a data, it should be shared using RSA. Okay, so the role of we need to check the role of different authentication protocols. Okay, we need to use RSA, we need to use AES, and we need to use the SHA. So now we're going to see these protocols and what are the role of these three protocols. So the protocols we're going to be using will be RSA, AES, and SHA. Okay. So when the laptop is sending the data to the server, it will be saying that I'm generating a public key and private key using an algorithm which is RSA. So basically RSA is used to generate the public key and private key. And we'll see how what is the role of these keys um, while sharing the data. Okay, and this RSA is called reverse Shamir element. Okay, and I'll be using AES, which is advanced encryption standard for encrypting the data for encryption. Okay, and the role of SHA, which is a secured hash algorithm, will be data integrity. That means nobody can change the data during the transfer. So that means when the initial message which is going to be sent from this laptop towards this server, okay, so the initial message contain these three algorithms. So when the server sends the certificate to the laptop, the certificate will contain public key of the bank, as we have discussed. Okay, so the certificate that will include the public key of the bank, which is C, and this will be sent to the laptop. And this certificate includes the digital signature done by certificate authority. Laptop sending a message to the bank server containing a secret key. Okay, so the laptop has a secret key which we call as S. This is a secret key. Okay, and this secret key will be encrypted with the bank server's public key. So bank server's public key, which is basically this C will encrypt this secret key. Will encrypt this secret key. Okay, so it will encrypt this secret key using a public key of the server. And once the secret key, this S will be sent to the server. This S will be sent to the server. And once this secret key, which is in encrypted form, will reach the server, and the server will decrypt this secret key using its private key, which is D. Okay, and this is how the secret key is shared between the laptop and the server. Okay, so the secret key is shared from the laptop to the server. So here we need to understand we are using a concept of public key and private key to share my secret key, okay, so that it can be used only symmetric encryption. So now we understand we are using public keys and private keys to encrypt the data, okay, so that the secret key is shared between the laptop and the server, okay, and this public key and private key algorithm is RSA. So the role of RSA here is to share the secret key from the source towards the destination, okay, and this sharing of the secret key is such a way that we only use a symmetric encryption. Now we understand the secure way of sharing a secret key between the source and destination using a key exchange. Okay, so I'll show you another example. Okay, so suppose laptop initiate a connection. Laptop says hello message towards the server. Okay, and this hello message is encrypted using three algorithms, which is RSA, AES, and SHA. Okay, so this hello message is basically encrypted using AES. Okay, and this initial message includes these three algorithms. Okay, and when the server respond to this hello, okay, the server respond the hello with the same algorithms, which is RSA, AES, and SHA. Okay, and it will also send a certificate along with that. Okay, so when the server sends its hello, okay, this hello is also contain these three algorithms, okay, which is encrypted using AES, okay, and it also include a certificate, which is basically a digital signature of the certificate authority, okay, and this certificate contains the public key of server. And when the server sends its hello, and when this certificate will reach the laptop will check this certificate, okay, and laptop get the server's public key on that also. When the laptop will check this certificate, and when the laptop will decrypt the signature with the public key of certificate authority, okay, when the laptop will decrypt the signature within that particular certificate using a public key of the certificate authority, okay, if the certificate is valid, the process continues. So that means the communication will continue. Otherwise, the connection will drop. Otherwise, it will drop the connection. And the secret key, which we have discussed earlier, basically this secret key is called master key, which is pre-master secret. And this secret, pre-master secret, it's a random value. Okay. And this one is encrypted using the public key of the server. This secret will be encrypted using public key of server. When it is encrypted using public key of the server, it will be sent to the server and server will decrypt it using its private key. And this is how the role of RSA will work using the public key and private key concept. Okay, so this public private key. So it's key exchange using RSA. Okay, so the secret is shared between source and destination using this RSA algorithm, or you can say public or private key concept. AES is used for encryption. It is used to encrypt the data. Okay, and SHA is used for data integrity. And within that, it will be using a MAC, MAC, which is message authentication code. Okay, so basically it will create a MAC, which is a message authentication code for every message which is sent from source to destination. Okay, and this particular code will be okay. So this particular code or the MAC which will be created for uh, every message, it will be done using SHA, which is a hashing algorithm. Okay, so this MAC is used to ensure a data integrity, just to verify the data does not tamper during the transfer or transit. So to summarize all these concepts, okay, so the role of certificate authority is to establish a trust between a source and destination using a certificate, okay, using a certificate issued to a server. So this certificate authority issue a certificate to a server, okay, and build a trust between a laptop and the server. So it establish trust between source and destination. Okay. RSA is used for exchanging the session keys, which is public and private key. Public and private. AES used for encrypting the communication or encrypting the messages sent from source to destination, and SHA is used for data integrity. Please watch my earlier videos if you have um, any difficulty understanding the concept of confidentiality, integrity, and authentication. So this data integrity is basically the same integrity, okay? And this I have explained in my and last to last videos also, okay? In case if you face any difficulty understanding the concept, please rewatch the video, okay? And if you have any questions, please drop a question in the comments so that I can help and answer the question for you. How or why this why SHA ensure data integrity? Okay, so this SHA, this hashing algorithm SHA ensure the data integrity. Okay, and this will make sure the hash is a unique value. This will ensure the hash is a unique value. Every tiny change in the message result in a completely different hash value. Okay, so if the message which is hello, or let's suppose this laptop is trying to make a transaction of $500, okay, and this transfer of $500 to transfer of $501, okay, these two transfers, $500 and $502, will generate a different hash value. Okay, it will generate one hash value, and this one will generate another hash value. Okay, so in case if it is sending any data or trying to make any transaction, the hash value which will be generated from source towards the destination, it will be same. The hash value which will generate at the source end will be matching at the destination end. And in between, if someone tampers the data and make a transaction of $501, and when it reaches the server that the user has requested a transaction of $501, it will create a hash of this value and it will get a different value. That means there is a tampering of data happen in between. Okay, and this hash value cannot be reversed to reconstruct the original message. So this the hash value cannot be reversed to reconstruct the original message. Means once the hash value which is generated at the source end, okay, when some intruder trying to check the data and when it see the hash value, he cannot get a original data from that hash value. Okay. Also the server, if the server detect any tampering by comparing the original hash with the recomputed one. So what the server will do is once the laptop will generate a hash of a data, okay, and when the data will reach at the server end, it will recalculate the hash of the data. Okay, and when both the hashes matches, the one which is generated at the source end and the one which is generated at the destination end, that means there is no data tampering happen during the transfer. So we have reached the data integrity. So data integrity is successful in that case. Okay, now we need to understand the TLS, transport layer security. Okay, over the control connection. First, there will be a TCP connection happen between the laptop and the server. So in TCP, the laptop will send the sync message. Server will respond with sync plus acknowledgement, and the laptop will send the acknowledgement back to the server. Okay, so here we'll be using a pair of public and private keys. Okay, the use of so these keys will be generated using RSA protocol. Okay, same here for RSA. Okay, we're gonna be using AES for encryption and SSJ for hashing at the laptop end, and same goes with the destination and with the server, where AES is used for encryption and SSJ is used for hashing. So the first message which is sent between the server and laptop, so the message is sent as a plain text, says hello. Hello is sent between the laptop and the server, okay, with no encryption. If the bank server is able to run the encryption, if the server is able to run the encryption using AES, able to do the data integrity using SHA, okay, and can generate the public private keys using RSA, then it will straight away go ahead and send the certificates. It will send the certificate back to the laptop. Okay, and this certificate will contain the organization name, serial number, okay, and it will include the public key of the server, which is C. Okay, and this certificate is by certificate authority, signed by certificate authority using its private key, which is F. So this laptop will also generate a secret key, which is S, and when this secret key will reach the bank server, okay, first this secret key will be sent from this laptop to the server, and it will be encrypted using AES. Okay, it will be sent to the server. Server will get this encrypted secret key, and it will be decrypted this key using the same encryption protocol. So it will be so at the laptop, and the same secret will be encrypted using the public key of the server, which is C, which is available on the certificate. So it will be encrypted using public key, which is C, and when it reaches the server, it will be decrypted using the private key of the server, which is D. So the same secret will be decrypted using the private key. Let's suppose if there is a data which is sent from this laptop to the server. So data sending from the laptop to the server, and let's suppose it's trying to access an application which is hosted on the server, or the application running on the server. This data will be encrypted. This data will be encrypted using secret key, and when it reaches the destination, it will be decrypted using the same secret key. Okay, and this complete the whole process of TLS or SSL. Okay, So the transport is secured here. So that's all for this video. Thank you for watching this video. If you have any questions, please put it in the comment section and do subscribe to my channel and like this video. So in my next video, we're gonna see the IPsec tunnel or the data tunnel between the VH routers. Thank you for watching this video. Have a wonderful day. Bye. Peace.